Thank you for having me. Well, transitions allow users to understand where things come from and where it goes to, much like this button over here. When I click onto it, it falls into the center and the title of my talk floats up. Yes, today I will be demystifying transitions in Svelte. And how am I going to do it? Well, we'll dive into Svelte transitions level by level. At the first level, we'll learn at how to use transition in Svelte. The second level, we'll look at how to alter a transition in Svelte. And the third level, we'll go deeper and take a look at how Svelte compiles and handles transitions under the hood. My name is Tan Lee Hao. I'm a software engineer at Shopee. Shopee is an e-commerce platform in Southeast Asia that is based in Singapore. I grew up in a lovely town called Penang in Malaysia, which has the best street food in Malaysia, such as char kway teow, stir-fry flat rice noodle, or rojak, an eclectic fruit salad with palm sugar, peanuts, and chili dressing. And well, these are just one of the many great street foods that I hope to try again after the pandemic is over. But last but not the least, I'm one of the maintainers of Svelte. So level 1, using transitions. Here we have a list of items rendered using the each block. When we add or remove item, the item appears and disappears in an instant. We have no idea where the item is coming from and where it disappears into. To add transition for the item, firstly we import a transition from a Svelte transition. Here we import fade, and to add entrance transition for the item, we add in:fade to the div. Now the item fades into existence. To customize the transition, we can add parameters such as duration or delay. And for exit transition, we use out:fade. And if you want both entrance and exit transition, you can use transition: the transition name. There are multiple built-in transitions in Svelte, such as fly, slide, scale, or blur, and many more. The list is not exhaustive, which I recommend you to check them out in the docs as well as the tutorials. Level 2, the transition contract. Not sure if you have heard about the store contract in Svelte, which states that if any object follows the store contract, that object can be used like a store, where you can subscribe to it and read the value like using a store using a dollar prefix. The same thing goes with transition. A transition has a contract. Any function that follows the transition contract can be used together with the in, out, or transition directive. Here is how the transition function should look like. It's a function that takes in two parameters: the element node the transition is applied to, and the parameter that is passed into the transition. And it should return an object that describes the transition, or return a function that returns the object. The object should contain properties such as delay, in milliseconds, how long will before the transition starts, duration, in milliseconds, how long the transition takes, easing, the easing function, which I'll explain later together with CSS, a function that returns a CSS string, and tick, a callback function. All of the properties here are optional if not specified. The default for delay is 0 millisecond, duration is 300 millisecond, and the default easing is linear. Usually you would want the transition to be customizable, and that's where the parameter is for. You can return the delay or duration passed into the parameter from the user. Now let's talk about easing. Easing describes how much an animation progresses at different points of time throughout the animation. For convenience sake, we describe time from 0 to 1, begins with 0% and ends at 100%. Here, as the red dot moves from the time 0 to 1 along the red line, the value of the ease time grows linearly with time? Well, the easing function that we're looking at now is the linear function. The ease value grows linearly with time. However, if I switch to cubic in, the ease value grows in the power of 3 with time, which is described in the cubic function over here. Here's why you use 0 to 1 for time, because 0 power 3 is 0 and 1 power 3 is 1. So after we power 3 the value of time, we still starts with 0 and ends in 1. But the easing function does not have to be a polynomial function. Here I'm using bounce out, which have like if else case for different parts of depending on the time. Or we can call a function another function within our easing function, such as this one, bounce in out. So how do we calculate time? At the beginning of the transition, we record the start time, and throughout the transition, we have t, the time passed since the starting time, in milliseconds. We divide the value of t by the duration of the transition. So now we get the value of 0 to 1 for t. So 0 is the beginning of the transition and 1 at the end of the transition. Now if I pass t into the easing function, in this case bounce in out, I'll get the ease value. The value does not go from 0 to 1 directly, and if I use the ease value to calculate how much I need to translate an element, I'll get an element that bounces in and out. And that's how the CSS function works. It takes in t, and you return a CSS style in string that will be applied to the element. You also have u, the second parameter, which is 1 minus t, the reverse of t. And as you can see, if you use u instead, then the element moves in the opposite direction. So if you use transition an element into view, the t will go from 0 to 1, but if you transition an element out of the view, t will go from 1 to 0. And if you want to manipulate element beyond CSS, you can use the tick function. It also takes in t and u the same way as CSS function. One very common use case of this tick function is to create a typewriter transition. Do note that the tick function is going to be called on every frame. If you want your application to be buttery smooth 60 frames per second, make sure the tick function is fast to prevent jank. So we covered all the properties in the transition contract. Let's take a look at an example of a custom transition. Here I applied a different font styles to the element. So the text stays bold and maroon for the first 40% of the time, and then italic for the next 40%, and then back to regular text. Well, 40% of the time is debatable depending on the easing function. In this case, we are using linear easing, so it is exactly 40%. As you can see, you don't have to limit your CSS transition to just CSS transform, or having to interpolate the value of t. The sky is the limit. Likewise, the text stays at coming soon at the first 40% of the time, before changing to the original text. Level 3. Compile transition in your head. This is a reference to the series of blogs I've written, Compile Svelte in your head. Be sure to check that out. As how we usually starts with Compile Svelte in your head article, we're going to explore how we can write a transition in vanilla JavaScript. There are a few technologies at our hand that we can make use of, and the first one is CSS transition. We add transition property to a selector, describing which CSS property to be transitioned, the duration, easing function, and delay. And when you change the value of specified property, in this case opacity, the opacity of the element will transition smoothly based on the easing function. So here I add the class to change the property to 0 and back to 1. However, CSS transition is a bit restrictive. You have limited easing functions. No offense, cubic Bezier is great. Another thing CSS offers us is CSS animation. We can define keyframes of the animation and then apply it to the element using the animation property. We can have multiple animations happening at the same time, as well as we change the value of the transformation. We can have different easing. Notice that we can still using linear easing in the animation property. So the keyframes will happen linearly, but as the transformation in each frame grows in cubic power, the element translates in cubic easing. We are no longer limited by the easing function provided by CSS. If the transition is not CSS based, we can use JavaScript. Request animation frame lets you tell the browser that you wish to perform an animation, and the browser will call the function provided for your animation update right before the next repaint. As you can see here, we can create a loop using request animation frame, and the loop function will be called on every frame right before the next repaint. In a loop function, we have similar code as we have seen earlier. We calculate the duration since the start and then set the text content based on the duration passed. So with CSS animation and JS animation, let's see how we can implement transitions in vanilla JavaScript. So here I have two buttons, add and remove. So add will call the insert new item, and remove will remove the item. So now we want to add transitions. Before that, let's take a look at the styles files. So here I have two CSS animation, fly in and fly out. So I want to call the fly in animation when I add the item, and when I remove it, I want to call a fly out animation. So here, as soon as I inserted the list item into the list, I'm gonna add the style animation. So I'm called fly in, 500 milliseconds, linear, no delay and no repeat, and yeah. So if I click add now, you can see that it's flying in, right? So for the fly out animation, here I play the animation, fly out animation. And instead of removing the item immediately, I'm gonna remove the item 500 milliseconds later, right? So it's take 5 milliseconds to play the animation and wait for 5 milliseconds before I remove the item from the list. So let me show you what we have right now. That's great, right? So now the next thing we want to do is to have like a bounce fly in animation instead of like a normal fly in. Well, I could manually write CSS animations, like manually write out the keyframes over here, but I would rather generate it using JavaScript. So the first thing I'm going to do is I'm going to copy the Svelte easing function. So I'm copy out the bounce function. The thing I'm going to do is to add a function called generate animation. So this file is gonna generate the keyframes dynamically. So first is that gonna determine the duration of the animation. So it's gonna be 200 milliseconds, which is 2 seconds. Then I'm gonna have a keyframe. So this is like how many number of keyframes that I'm gonna insert into the animation keyframes. Well, I don't have to insert too many frames. It depends on how long the duration of the animation is going to be, right? So it's going to be at most 60 keyframes per second because the browser won't render more than that, right? So 60 frames per second would be 16 milliseconds per frame. So calculate how many frames will be using duration divided by 16.66. Right, and then the next thing, okay, so probably should round it up, right? Because because we want the total number of keyframes, then we're gonna loop through this number. So now I'm gonna create the rules. So I'm gonna have keyframes over here. I'm gonna name the animation bounce in. I'm gonna fill in the animation, the frames over here, and to add the rules, to apply the rules on the HTML document, I'm gonna create a style tag first. And then I insert the style tag into the document head. And then I'm gonna append insert a rule to this style tag. So it's called style.sheet.insert rule, and pass in a rules string. Okay, this will insert the rule bounce in. Right, so now the next thing we're going to do is to fill in this part. So what I'm going to use is using array dot map. So I'm going to fill in this array with null, and then I'm going to, sorry, I missed an S over here. Fill in with null and then map it, right? So what it's gonna look like is that, sorry, over here is a string, and support. So it should be something like %, and then we're gonna transform x, translate y, and then number pixels, right? So I'm gonna fill in the 0% and 0 pixels based on the rule. So firstly, I need to know that the t, right, as we've seen earlier. So the t here is calculated as the index divided by the number of keyframes. And then the isT will be based on the easing function. So we pass in the t value to the easing function. And once we have the isT, I'm gonna fill that in over here. Sorry. So we're gonna have is, we're gonna start from 0 to 50. So we're gonna start with like negative 50 to 0. Okay, so I'm gonna start with 50 pixels and then slowly moves to 0, right? So 1 minus t will give me 1 to 0. It will give me 1 when the t is 0, and then 0 when the t is 1, right? So I'm gonna move from 0 to 1, and then times 50 will give me 50 to 0, right? And then for the percentage, this will be based on t, and it's gonna be a percentage, so I'm gonna times 100, so it's gonna be 0% to 100%. And so this should be the is t. And lastly, what I'm gonna do is to join all of them with new line. Next one we are gonna do is to have a 100% case. That's because index starts from 0 all the way to n minus 1, right? So we're gonna have a n case where n will be the maximum number of keyframes, right? So here it will be the target. So it will be translate y to 0, right? Yep, that's all. So let's see what we have. So before we're gonna see what's gonna happen, we're gonna use this generate animation. Alright, so we're gonna generate animation once, and then we, instead of using a fly-in animation, we're gonna use bounce in. Save that, and now we have a bounce in. Next thing we're gonna try to do is have like a typewriter exit for the list item, right? So that can't use CSS animation, so we're going to use a JS animation. So firstly, you're going to design a function called start JS transition. That takes in an element and a callback function. So how that work is that I'm gonna use it first. So I'm gonna pass in the list item that we're gonna remove, and then the callback function is actually this one, where it will be called to remove the list item when the animation is done. Right. So over here, we're gonna start the loop. So we have a function called loop, and over here we will request animation frame loop and copy this over here, and then so this will create like a loop for each frame. And when we start, we need the duration. Same thing, we're gonna do like 2 seconds, so it's 2000 milliseconds. And then we're gonna record the start time, and we're gonna record the end time. That will be the start plus duration. Right, so to do the typewriter kind of effect, we need to first record down the initial text content of the element. So here I'm gonna say text equals to list text content. So here in each loop, we're gonna know what's the time right now. So that now equals to date.now. And then if the time has already passed the ending time, then we're gonna call the callback function and end it right here. Right, so this will break the loop and it will not gonna go infinite loop anymore. If it's not past the end time, meaning we are still in the transition, so now we want to know what's t value over here. So calculate t, we're gonna minus the current time with the start time and divide by duration. And to make things easy, the is t for now is gonna be t, so it's like a linear easing. And then we're gonna have set the text content based on the is t. So I'm gonna slice the string. Sorry, it's gonna this element. It's gonna count element. So it's a text. This as well. Sorry. So it's gonna text dot slice 0 math dot round times 1 minus is t. Again, it's the same thing. Is t starts from 0 to 1, so I'm gonna get 1 minus is t, so it will go from 1 to 0. So 1 will be full length, so we times the number of length will be the full length, and then we slowly move to 0, which is 0th length. I'm gonna slice that part of string and then set it to the element text content. So here I bounce in and typewriter exit. The next thing we're going to do is to have a util function that combines both CSS animation and JS animations, and that will resemble like how Svelte animation looks like. So right here we're going to have a function called transition in, and that will take in an element and duration, delay, easing, CSS, and tick. So it will be taking in whatever the transition contract is passing in. Right. So So firstly we need to create CSS animations, right? So we're gonna get the name. So bounce, we're still going to call bounce in because I'm lazy to think out a new name. But for each bounce in, we're going to have a custom identifier, right? So I'm going to use I. So let I equals to 0. So every time we call transition in, we'll create a new animation name. So depending on like what CSS functions you are passing in, a different function will create different CSS animation rules. Next thing is we're going to copy what we have previously. So we're going to copy like the duration and the keyframe. So probably just the keyframe. Right, and then we copy the code for generating the rules. So now instead of bouncing, we're going to have a custom name. And instead of having manually a hard-coded transition, we're going to have CSS. We're going to use the CSS function to generate it for us. So we have est over here and 1 minus est. Right, and here as well. So we're going to have CSS one and 0, right? So this is the end and this is the beginning. Now next thing we're gonna have is we're gonna copy how we're gonna insert the style sheet. And lastly, we're gonna apply the animation to the element. Right, so instead of doing this, we're gonna have it over here. It's gonna be renamed to element, and bouncing will be renamed as name. And then this should be the duration, and this gonna be the delay. Right. Then the next thing we're gonna do is that let's try this out first. So transition in, and then we're gonna have delay is 0, duration is 500 milliseconds. And then CSS will be pu return transform equals translate y px. Okay, the template literal, and then this would be u times 50, for example. Close this, and let's take a look. Yep, still behaves the same. So the next thing is we're gonna incorporate JS animation inside transition in as well. Right, so once we inserted the rule over here, we're gonna start the JS transition as well. So we're gonna copy the start and the end time, JS animation, and then we're gonna copy the loop, and here instead of so here at the very beginning we're gonna call tick at 0, and when it ends, instead of callback, we're gonna call a tick 1 and 0, right? And over here it will be tick est and 1 minus est, right? And that's all. Okay, so hold on. So tick, gonna have tick over here. That's nothing, so just make sure everything still works. So we're gonna use the transition in for actually transition out the last item. So yeah, CSS gonna return an empty CSS string. But then for the tick, gonna have if t equals to 1, gonna remove the child, right? But then over here we need to change the string as well. So let's see, we copy this one. Alright, so we record the text at the beginning of the transition, and when it's transitioning, we're gonna copy this to set the substring of the text. Alright, so else gonna so add, remove, add, remove, right? So here we refactor transition into one function that takes in the transition contract, and we have duration, delay, easing, CSS, and tick, and we reuse it for both transition in and out, right? So it doesn't have to be for just adding things in, it could be out transition. As we have seen how we can implement transitions in vanilla JavaScript, let's see how transition is compiled by Svelte. If you have read my compile Svelte in your head block series, you should know that's create fragment function. To those that haven't read it and have no idea what create fragment function is, well, go read it. What are you waiting for? Anyway, a create fragment function is part of Svelte compiled code. It returns an object describing how to create, mount, update, and destroy elements for the Svelte component. And you can think of it as recipe for Svelte components. And create, mount, update, and destroy are the basic operations of all Svelte components. Here are two more operations added if you use transition, intro and outro. And let's see how is it being used. Say if you have a each block. So in the main create fragment function, you create a each block, and you have the create each block function that has the recipe to create elements for individual each items. In the create fragment function, we call transition in and transition out in the intro and outro function. This will in turn call the intro and outro method in the individual item block. And when the each block has changes, say adding a new item into the array, Svelte will also transition in the newly created block. And when the item is removed from the array, Svelte will start a new group of outros, transition out of the removed items, and synchronize the outros. Let's take a look how the intro and outro method look like for each item. First, in the intro method, we'll create a bidirectional transition for the div, the element we applied transition on, if it has not been created, and run it to 1. For the outro method, on the other hand, we run the transition to 0. Here, both of the intro and outro is sharing the same transition object, so if the item is added and removed immediately, we can run the transition to 0. The intro animation is cancelled and outro animation is played immediately, depending on the outro delay. If you only use the in directive, on the other hand, then only the intro transition is created. And likewise, same thing goes if you only use the out directive. Now let's take a look at how create in transition look like. Hopefully you can see like some resemblance with the vanilla code that we've just written. We're going to look at the create in transition as the create out transition and the create bidirectional transition is almost similar in structure. So firstly, we have the start, invalidate, and end. And the start will call the go. So we'll take a look at the go function. So the first thing is we create the CSS rule where we construct the keyframes and then we insert the keyframes into the style sheet, and then we apply it to the element. Next, we start the loop. So if you look into the code for the loop, it's using request animation frame. Before we start, we need to record the start time and the end time, so we know when it will end and start. And we call the first tick function. If the current time has passed the start time, we calculate the is time and call the tick function. And if the time has passed the end time, we'll call the tick function one last time. In the beginning of the loop, we dispatch on intro start event, and when it ends, we dispatch on intro end. And now, of course, some cleanup after that. Well, here are some source code reference if you're interested. First is the internal transitions, where the transition in, transition out, and create in transitions method are being defined. Following is the internal style manager. Here's where you can look at Svelte's code on how to create new keyframe rules and manages the style sheets. Lastly is the runtime transitions. That's where you import Svelte transition from. You can check out the code for, let's say, fade, fly, slide, crossfade, and many other transitions. So finally, a recap. We have seen how you can create a transition in Svelte, alter a transition in Svelte, and finally how Svelte implements transition mechanism. Hopefully, transition is no longer a mystical feature to you, and I hope to see more creative transitions coming up. So tag me on Twitter or Discord at LeeHaoTan. If you created something cool with transitions, I look forward to see them. And once again, I'm at LeeHaoTan on Twitter. Follow me where I post cool and fun knowledge about Svelte. Thank you and enjoy the Svelte Summit.